Hello everyone and welcome. So in this video we'll be creating this ribs model mostly by using volume noises and procedural modeling techniques. So yeah, let's get started. So as always, let's start with a geometry container and we will drop down a line along the z-axis and we will place it in the center. So let's copy the length and paste on the z, divide it by 2 and make it negative, so we scale from the center. I will add 7 points and we'll place a nonlinear because I will use it later. So now we want to sweep this, and for that we need a profile. So let's create a lab simple shapes, and it will be a quad and on the XY plane, and let's not make it equal size, and copy the top to the base so we can scale it accordingly. And on the height I'm gonna say 0.09 and on the top 0.3. Oops. And on the top 0.313 was the value I found, was working great. So now let's sweep it and we will use this cross section, and I believe we need to round it. Yes, yeah, we need to round it. So let's go with round corners and 0.02 and 4 divisions, so something like this. And now when we sweep it, and now let's add a normal, and we will also subdivide it twice, and we will create some deformation. Actually in here we need to create the end caps, and I'm gonna change the scale to 0.3 and 3 divisions is fine. So we have this. Now we need to create a mountain to deform a bit the shape first. So let's create a mountain, and it will be a really low amplitude, 0.03, and we want it 0 centered and the element size of 0.27. I'm just copying some values, but feel free to use your own. So let me see. Yeah, this looks similar. Now we might get some intersections in here, so let's blur the normals. So point normals and attribute blur on the end. We've done this several times and it does help a little bit on the corners. So yeah, let's get right into the volume displacement, but before that let's just place another subdivide to make everything a bit smoother, and let's move to the volume displacement. Okay, now VDB from polygons, we'll create an SDF out of this model, and the final resolution will be smaller, but for now let's go with 0.005. And we need to smooth it a little bit, so VDB smooth SDF. And I believe default iterations are fine. And let's move to the volume VOP. So volume VOP. and also convert VDB to polygons so we can preview our result. So I'm just going to create some initial displacement, so with an AA noise, anti-alias noise, connect the position to the position, and we can create a constant in here and then multiply constant. This is the usual setup I do, because if we increase this multiply by constant, we can increase the repetition of the noise. Let's place also a fit range so we can control our values, and also another multiply constant to have an overall control. Then we can also place a switch to turn on and off the noises, so output 0, connect this to here and just place an add. And I like to color them yellow, and let me see, we need actually to do some things in here, so let's change this to density and let's use world space, and I believe I need to increase it, so actually increase it quite, fill interior and increase it quite a bit, the exterior band. So now it's working because we were not binding the density. And as I said, this is meant to be just an overall noise. So first of all, I'm going to increase the multiply constant, the repetition of the noise, and on the noise itself I'm gonna decrease the roughness to 0.35, and on the feet I'm just gonna expand it, so minus 0.15 minus 0.15, and decrease quite a bit this one, so 0.1. So it's just an overall noise, as you can see, just to break a bit the shape. And let's move to the second one. So let's create an AI static noise, so it's not AI, unified noise, I mean. And let's connect this to the position and create a constant in here. Oops. So create constant and multiply constant, and we will also need this tree in here so we can copy, and let's add it in here. Let's just make sure we untick this one, as we don't want to preview that noise. So we need to do quite a few things. First of all, I'm going to increase the repetition of the noise to 8, and I'm going to also change the noise type to Worley Cellular F1, so we get this sort of shape. I have an offset of 80, so I'm gonna replicate it, but feel free to use your own values. And I also I'm going also to increase it, in this case to expand it by 0.3, and a multiply constant will be smaller, 0.075, so something like this. Now we want to distort this noise, because right now it's looking to procedural or to computer generated. So for that I'm going to use a turbulence noise and connect the position and edit. And since we want to distort in positive and negative, we will use it we'll use sparse convolution and 3D noise. And let me see, we need to change the amplitude. It's too high right now, so 0.27. And I'm gonna also change here the repetition, so the frequency to 0.21x. So we have this directional noise. And also I'm going to transform the position to be like in a diagonal way. So for that I'm going to use a transform matrix. How is it called? Transform matrix, yes. I'm going to place it here and rotate it 45 degrees. So let me just check on the turbulence noise. I'm gonna offset this. So I'm gonna use some values from before, as I was telling you. So this one looks a bit better. It's more likely what I want to do. And I believe we only have one noise left to do. So let's actually duplicate this setup. And you can drag these to the shelf and keep adding them without having to rebuild them every time. Or you can use a receipt now in Houdini 20.5. So I'm gonna actually remove this X form, and let's see what else we will need to change. We'll increase the repetition in here, the frequency to 0.6, and increase this. And now we want to just to create some overall deformation, some finer detail I mean. So I'm gonna offset this just to be different. And maybe change the amplitude. And this will be our distortion. Let me just check. So now we will use a different noise, wireless cellular F2 F1, and we will complement it. And now we need to play with the feet. So in the feet we will say -1 and a small value on the destination max. So we create something like this. Now we also need to decrease this quite a bit, so 0.02. So we have something like this. Let me just check. And of course we need to add some fractal. In this case we will do standard. And 1.56 was working fine for me. And I believe that's all. Let's enable all the noises. So disable, enable. So this is our low resolution preview. Now let's increase to the final resolution and see how that goes. So 0.0015. So this is the result we got. I believe it's pretty similar to what I have in my final file. And this took about 30 seconds to cook, so depending on your machine, mine is really bad, so you'll probably get away with a faster result. So now we can leave this part in here, but usually it's cut, right? Is more straight. So I'm gonna use some boxes to make this planar on the sides. So bear with me. We'll create a box. And let's preview this and create a box. And this is where we need to move it. And let's resize this. Maybe increase in here. So something like this. 3, 4. Is similar to what I have. So let's do a mirror and mirror on the X. And we need to add some subdivisions, so 20. So we can displace it a bit, so with a mountain. And the values I have were about 0.03 and 0.4 and 2.7. So something like this will be fine. And now let's subdivide, and we will subdivide twice to have a smoother input, so twice. And let's see, is this okay? I guess so. So now let's create a VDB from polygons, and this will have a resolution of 0.01, which will be fine, totally fine. And let's do a VDB combine, and this will be a bit slow when we do the subtraction or difference. So more 20 seconds more now, and I believe we need to move it a bit more in. So let's see, let's check this and move this a bit more in. So in this case I had a value of 0.31, so something like this. And let's test that. So let's look at the final result, and yeah, this is more like it. And we will add some noise on the sides, so don't worry about that. And now we will do exactly that. So let's create a volume blob, another one, and we will also create another VDB from polygons in here, from these boxes, so we can mask the sides. And let's do a fog VDB, since we want to mask, call it mask, and we can use this and connect this to the second input. So we will copy the detailing from this one, so let's copy this last noise and paste it in here. Oops. And let's edit. So edit. Let's move this. This will take a while, so we better decrease this for now so we can concentrate on the effect, and we will increase it at the end. So this is much faster. And now we need to mask that. We only want on the sides. So we connected the mask to the second input. Now we can do a volume sample and connect the second input in here and the sample position, and we will do a primitive name and mask. And now we can simply multiply it. So in here, let's create a multiply and multiply this with a fit range. We'll need a fit range in here and multiply it in here. So as you can see, it's not doing much because we need to play with the values. So let's go with a source max of 0.1, and this still has some flat areas. So what we can do is to place a transform and scale it a bit. So transform, and we can and we can scale it a bit, so 0.8, and let's see the result now. And now it's affecting all the sides, so as you can see. And maybe we want to play with the texture on the sides, so let me see what else did I change in here. So let's change the amplitude in here to 0.25 and increase the frequency, so we have a bit more distortion. Sparse convolution, 3D noise, and let's see, this one is fine. I maybe want to play with the offset, and the rest is fine, I believe. Let me see the fit, multiply, and yeah, that's all. So now we just need to increase the resolution. So how much was it? 0.0015 and 0.0015. And let's look at the final result. So lots of detailing, but maybe we want, I'm noticing a seam in here, so maybe we want to, let's change this to 0.003. Sorry, it was 0.003, almost crashed my Houdini. So maybe in the transform in here we can increase this to 0.9 so we don't have that visible seam in there. It didn't happen in my initial file, so I'm not sure what I've done different in here. So I don't know what we can do, so maybe reduce in here, so 0.25. Yeah, that helps quite a bit, so that's fine. Let's increase it again to 0.015, and we will look at final result, 0.0015. So let's look at this. Now it's more clean. and we don't have that sort of issues. So let's cache this. So file cache, and let's name it ribs noise demo, and let's save to disk. Let me just check. So it's looking pretty similar to my final result on the other file, so it's fine. Now we'll create the bones. So now for the bones, let's object merge that initial curve. So let me actually have some more space in here, and we will merge this curve in here. And let's see, now we will transform it a bit. So translate it by 0.08 and scale it 0.85, and we still have those points. Now we can create the bone. So for that I'm gonna place a circle, and we will do this in a loop to have some variation, but for now I'm gonna just place some initial values. So divisions, we can set this to 5 for now, and create a bevel, and it will be on the points, and let's say distance of 1 and divisions 3. And now let's create a random p-scale, so let's put just float p-scale, and we want random between 0.28 and 1, and let's say this seed, and now let's scale that by attribute, so we get this random scaling. And let's extrude this, so extrude, and we'll go a distance of 3 and 7 divisions. Let's blast that primitive 0, so we have in here, so blast primitive 0, and now mirror. So on the Z, let's polyfill it, in this case quadrilateral grid. Let's untick the form patch, and what else can we do? We can extrude this a bit in, so poly extrude, we can inset it, so I'm gonna inset it by 0.13, and it will be the patch group that we didn't save, so patch group. Now let's extrude them in again, in this case the output front, so output front, and I'm gonna extrude it just a little bit. So now we can create a bend. Let's press enter and B, increase the angle, and keep pressing B until we find, so this is it. And let me check, is this it? I guess so. So Now we will create again a bevel. So let's do the same setup from here. So we can copy these nodes and do a poly bevel, and we will bevel the hard edges. So let's exclude, and a distance of 0.02, and scale it by attribute, and 3 divisions, just to add some details. We will mostly do it with textures, but I will be creating that tutorial in another video. So let's go with 17, and I'm just setting this up initially, but in the end we will create a system with a for loop, subdivide, and finally do a match size, and we want to align it on the Z, I believe. So in the Z I'm gonna set it to min, so something like this, and UV unwrap. In this case, let's skip the UVs for now, since we will create the textures later. So now we can copy the points, and of course we need to change a few things. So first of all, let's set an initial normal, so attribute adjust factor, and we will set the normal along the X, so like this. Another attribute adjust factor, but on the up, and we will set it to the y-axis, and yet another one, and on the N, and now let's see our normals. Now we want, oh, not the M, N, and now what we want to do is to create we want to randomize the orientation, so let's set it to direction only, and rotate, and from attribute, and we want to rotate around the up vector and set it to random. So as you can see, it's creating this effect. So let's maybe change this, copy and paste, and do it negative, and I'm gonna use a value of 13 and change the C to 44. Let me just check. So yeah, now we'll just create a point cheater to add yet another layer of randomization. 0, 0 on this axis, and 1, and a scale really small, 0.08, and a seed. I'm gonna use the same value, but you can play around and untake update normals, otherwise it won't work. And let's just attribute just float for the B scale, and we will do a random value between 0.03 and 0.05. This will be enough, and we can just change the seeds. Let's see how that goes. So it's copying to the right direction, but now we need to do this in a loop. So we have some random bending and all the other attributes. So let's create a for each point. Copy this in here, And the first thing we're going to do is to change the sides of the circle. So first of all, let's create a meta import. So create meta import and call it meta. Oops. And we will connect it to the circle. So add spare input and connect it in here. Let's copy this down. So now we will need a seed, so let's edit parameter interface. Let's add an integer and call it seed, and a value between 0 and 100. So now we can, on the divisions, we can do a fit, so 1, and the random. On the detail, -1, which is the spare input, and we want the iteration, and 0, and we want to add this seed, so base relative references, and between 3 and 5. Let's see how that goes. So we have 4, 4, 5, and in here we have 3. So, and let's change the seed also. So as you can see, it's changing randomly the amount of divisions. Another thing we need to do is on the bend. So again, let's edit parameter interface, create an integer seed, so it's fine. Let's also add spare input, and it will be our meta. And let's copy the same values in here. So where were we? So let's copy this, because we will do a similar thing to 1, and we will do between -30 and 35. So something like this. As you can see, we have this randomness. Let me check if my file looks like that, otherwise I might be doing something wrong, and it does, so it's fine. So now that I'm seeing this env unwrap, maybe we can place it elsewhere. So actually, let's leave it there. And now, since we're doing copy to points, it's always a good idea to compile it, so I believe it won't complain, which is always a problem with compile loops. Let's multi-thread it, and it's working fine. Let me check my UVs, because this looks indeed strange. Yeah, let's keep it like that for now. We can fix that later. So I guess that's about it. Let's merge these with our meat. So let's copy these and merge it. And this is our final result. So this is the work in progress I have for the next part on the texturing and shading, so stay tuned for that. And other than that, just check out my Patreon if you want to support my work and download all the project files, including this one, on there, and I'll see you next time. Thank you.